Now we will move on to the global surface pressure pattern and the general winds. As we saw earlier, equator get more insolation and the temperature is high over there. So a corresponding low pressure area will be formed there. Similarly, due to low insulation and temperature, a high pressure forms over the poles. So a low pressure over equator and high pressure over poles. So obviously a general wind should be blown from the polar high to the equatorial low. But actually what happens is the equatorward wind from the polar high, the high pressure area undergo surface heating along its way and lead to rising of air at the subpolar levels, that is around 60 degrees, and this create a low pressure area there called the subpolar low. At the tropopause level, this wind diverge and blow towards pole and equator because the vertical winds cannot shoot to the stable stratospheric levels. Both these upper level winds undergo radiative cooling en route and sink when they become heavy. So, a polar cell of circulation forms in this way with an equatorward winds at the low level, an uplimb over the subpolar region, an upper tropospheric poleward wind, and a downlimb over the poles. The rising limb of subpolar low also produce an upper level equatorward wind which undergo radiative cooling en route. I hope you know that the air heating occur only from the ground. Thus, this upper tropospheric winds sink as it cools at the subtropical region, that is around 30 degrees, creating a high pressure belt over there called the subtropical high. The sunk air winds blow to both the sides, equatorward and poleward, from the subtropical high. The poleward moving air move towards the subpolar low and undergo surface heating. This is the Ferrel cell with uplimb over the subpolar low and the downlimb over the subtropical high. The surface winds are towards subpolar high and the upper tropospheric winds are equatorward. Now from the subtropical high, surface winds blows towards the equatorial low. Due to tremendous surface heating, large amount of vertical motion occur there and shoot up to the tropopause. There, the wind diverges to both the sides. This diverged air undergo radiative cooling and sink at the subtropical high. This forms the Hartley cell with the uplimb at the equator and the downlimb at the subtropical high. Since the only moisture source is the Earth's surface, all the low pressure areas or the uplimb areas will be of high relative humidity. The sinking air from the upper troposphere will be dry and thus the relative humidity over the will be low over high pressure belts. So we can find most deserts over this subtropical high region. Of course, there are other factors too. So in general, this is the pressure pattern: equatorial low, subtropical high, subpolar low and polar high. Wind always blow from high to low. Coriolis force affect the wind and follow a pattern like this in the first figure. I hope you know it. But in actual, you cannot find an ideal pressure pattern as shown before, but highs and lows will be scattered almost close to the ideal pressure pattern. These highs and lows show seasonal shifts also. These two figures shows the pressure pattern during the months January and July. Now coming to the precipitation pattern, you are familiar with these figures now. So we can see here itself the possible regions of precipitation. Clouds form wherever there is low pressure and convergence. So at the equatorial and subpolar belt, we can expect rainfall frequently. The sinking air of the high pressure belts are dry as they are coming from the upper troposphere. So we can expect rare clouds or rare rain events over these areas, that is over subtropical and polar region. In order to see the seasonality of rainfall, I have divided the whole latitudes into 7 regions as shown in this figure. The first area will be always wet. That is, seasonal shift of this low between summer and winter occur within this area, that is equatorial belt, and thus get rainfall throughout the year. The second region get rainfall when the equatorial low shift towards it during summer. During winter months, the dry subtropical high shift towards here and will be a dry season. Thus, this area will be wet during summer and dry during winter. The third region lies in the high pressure belt, the subtropical high. It is a dry region. Seasonal shift of this high doesn't bring low or clouds here, and thus this region will be always dry. The fourth region lies in between the subtropical high and subpolar low. During summer, subtropical high shift towards this area and will be dry. During winter, subpolar low shift towards here and thus it rains. So, this region will be dry during summer and wet during winter. Subpolar low region is always wet. Seasonal migration occur within this region and are characterized by frontal cloud activities. The sixth region is characterized similarly by wet summers by the seasonal shift of subpolar low and dry winters due to the shift of subpolar high. So this region will be characterized by wet summer and dry winter. The seventh region, the last region, lies over the polar high pressure region and is always dry due to the sinking of air from the upper troposphere. So, I want you to draw a plot in your notebook on the latitudinal distribution of evaporation and precipitation. Search on internet. So, I am done with today's class. Thank you.